Hello good people, I'm going to talk about hydrogen bonding and water. It turns out that water is rather amazing, and this is due to the fact that water is a polar covalent molecule that is really great at hydrogen bonding. It is hydrogen bonding that is responsible for several properties of water. Firstly, we have the boiling point of water. It is 100 degrees Celsius. Now this is rather high for such a small molecule. Other molecules that have a similar size or similar molecular mass have a much lower boiling point. For example, ammonia boils at -30 degrees. Methane boils at -60 degrees. And this is because those other molecules are not as good at hydrogen bonding as water is. The next property of water that I want to talk about is water's heat capacity. The specific heat capacity of water is 4.184 joules per gram Celsius. What does this mean? It means that we need 4.184 joules per gram of water to increase the temperature by 1 degree Celsius. This is a substantial amount, so we can say that it takes a fair amount of energy to increase the temperature of water. And you may have experienced this when trying to heat up some soup or when you look at your energy bill. In part, this is why when you are on the beach, the sand feels much hotter than the water. They have both been exposed to the same amount of energy coming from the sun, but it takes far less energy to heat up sand than it does to heat up water. The next property I want to look at is the heat of vaporization. The heat of vaporization is the energy required to convert 1 gram of liquid water into a gas, into steam. And once again, it is quite a substantial amount, 2257 joules. Note that it is much higher than the specific heat capacity of water. So while we require a lot of energy to increase the temperature of liquid water, we require even more to convert that liquid water into a gas. The heat of vaporization is usually expressed using one of these two units. Either we are talking about joules per gram or kilojoules per mole. Recall that the word mole stands for a Lada Raj number, 6.022 times 10 to the 23rd. So if I want to convert 1 mole of water molecules from liquid to gas, I will need almost 41 kilojoules of energy. You may have experienced this when you're trying to boil some water for pasta. Firstly, it will take a lot of energy to heat water up, and then even more to get the water to boil, to get it to change its state. Next property I want to look at is density. Density depends on temperature, and for most matter we observe that as we decrease the temperature, the density increases. And it turns out that at 4 degrees Celsius, the density of water is 1 gram per cubic centimeter. However, if we cool water further, something interesting happens. The density starts to decrease. By 0 degrees, water is a smidgen under 1 gram per cubic centimeter. And once we convert liquid water to solid water, the density is substantially less. It is 0.917 grams per cubic centimeter. This is why ice floats on water. And you may have experienced this when you drop an ice cube into your favorite drink. Fair enough, but how do we explain this in terms of hydrogen bonding? Well, we need to look at what happens at a molecular level. So here we have a bunch of water molecules. They are randomly moving and forming and breaking and reforming the hydrogen bonds. It is all rather chaotic. And not all hydrogen bonds are of the same length. Some are longer, others are shorter. How does this compare to the molecular arrangement in ice? As we cool water down, the molecules start to arrange themselves in a more orderly fashion. We end up with a lattice structure. The hydrogen bonds are now all of the same length, and all of the water molecules are equally spaced apart. What is really important for density is that in ice, the water molecules are actually further apart than they are when they are in liquid state. In other words, water expands upon freezing, and you may have experienced this if you left a full water bottle in your freezer. Alright, finally, I would like to talk a little bit about the emergent properties of water. There are 4 emergent properties of water that are linked to hydrogen bonding. And these 4 emergent properties of water are cohesion-adhesion, moderation of temperature, expansion upon freezing, and solvent of life. In many ways, these 4 emergent properties are just another way to talk about properties of water. So when we talk about cohesion and adhesion of water, we are referring to the fact that water is sticky. Water molecules will hydrogen bond to other water molecules, that is what we refer to as cohesion, but water molecules can hydrogen bond to other things, and this is what we refer to as adhesion. So in short, cohesion is water sticking to itself, adhesion is water sticking to other things. And you may have experienced this when taking a shower. Individual small water droplets will join to form bigger droplets. What is more, those droplets will stick to the glass of your shower cubicle. Fair enough. What is moderation of temperature all about? Well, it is linked to the specific heat capacity of water. Recall that water can absorb quite a lot of heat before it increases in temperature. Large bodies of water can influence the temperature in the surrounding areas. And this is why coastal areas experience a smaller variation in temperature between day and night than areas that are further inland. In a coastal area, water will absorb a lot of energy during the day, and then during the night it would release that energy back into the air. On the other hand, if we are talking about an inland area, the moment the sun goes down, the air will start to cool, and there is nothing to provide further energy to it, and so there could be a large drop in temperature. This is also why deserts experience high extremes. During the day, the temperature might be close to 40 degrees, whereas during the night, we might approach freezing temperatures. And so, in simpler terms, we could say that water has a great ability to store and release energy. The next emergent property is expansion upon freezing, and that is linked to density that I described earlier. And in very simple terms, this means that ice will float on liquid water. This is very important for lake and river life in colder regions. If ice were more dense than liquid water, every time surface water freezes, it would sink to the bottom. And then surface water would freeze again and it would sink to the bottom until the entire lake is frozen solid. This would mean that every single creature inside would die. But that is not what happens. Because ice is less dense than water, the top surface will freeze and then it will remain on the top, insulating the rest of the liquid water and allowing all the creatures to survive the winter. The final property of water is solvent of life. It turns out that water is capable of dissolving more other substances than any other liquid at ambient temperature. In fact, our cells are mostly made up of water. And so most of the biochemical reactions that keep us alive occur in water. Please note that this was just a short summary of the 4 emergent properties of water. Each one of these could be explored further, but I will leave that for another time and another course. For now, I hope that you can appreciate how truly amazing water is, and how the amazing properties of water are ultimately linked to hydrogen bonding. That is all for now, and I will see you on the flip side.